Now we're going to take this a step further. We've got Braden, Ellie, Michael, and Zach are all applying for 2 lifeguard positions at the YMCA. How many different ways can they pick the lifeguards? Since there are 2 choices being made, tables are lovely for this. Braden, Ellie, Michael, and Zach. Braden, Ellie. Leave some space because you got to write out your sample space. Can I pick Braden and Braden for these 2 positions? No, so I'm just going to put a line there, no entry there. But I can pick Braden and Ellie, or Braden and Michael, or Braden and Zach. I can do Ellie and Braden, not Ellie and Ellie. Ellie and Michael, Ellie and Zach. Michael and Braden, Michael and Ellie, no Michael, and Michael and Zach. Zach and Braden, Zach and Ellie, Zach and Michael, and no go there. Alright, so how many total outcomes do I have here? Well, I have 12 outcomes. But some of you are going, wait a second, it should be 6. Well, I said 12 total outcomes, and it's good to know this number. It might come into play later when we're doing probability. Understand that with the dupes, and we'll talk about dupes, there are 12 if I include them. Alright, so but really, we want to know how many different ways. Well, some of you probably say there are 6 different outcomes, right? 6 different outcomes, because picking Ellie, then Braden, and then Braden and Ellie, are those the same outcomes or not? Well, does it really matter? No. Why doesn't it matter? Both positions are the same. So position doesn't matter. Alright. What would be the answer if we use the permutations formula? Well, that would be the 4p2, or basically 4 times 3, because you had the 4 factorial anyways. You're going to get 12. Alright. How many different ways can I order the choice of Braden, Ellie, and Zach? How does this explain the difference between your answer and what you got from the permutation formula? I should say, this looks like a typo. Alright, well, I can do Braden and Ellie, or Ellie and Braden. So I have to, this is 2 times, right? And the idea is that you have to divide your answer, we'll call it answer even though it's not your final one, by the number of ways to arrange 2 people for this problem, right? Okay. So in permutation problems, position does matter. That we were doing permutations. It does not matter for combination problems. These are combination problems right here. Everything we've been doing before, when I started talking about permutations, everything before this on this set of notes has been permutation problems. So let's see if we can tell the difference. When do we use what? Well, drawing 5 cards from a deck. If you're playing, poker or some other card game where you get 5 cards, it doesn't matter if you have the ace first or second. You are allowed to rearrange the cards in your hand. So this is where position does not matter. The nice thing is permutation and position start with the same letter. Alright? Picking the batting order. Now some of you, amazingly, don't follow baseball or softball. But if you did, you would know that position matters very much, and people are very excited to hear what the batting order is for the big games. Picking officers for a club. Trust me, the president and the vice president know there's a difference in their positions. Picking flowers for a bouquet. If I pick 3 red roses and 2 white lilies, it's still the same if I pick 2 white lilies and 3 red roses. It doesn't matter when I pick the flowers, because they're just going to get all jumbled up together, hopefully beautifully, in a bouquet. Picking 2 books for a trip. Position does not matter. It's a combination, because the books don't care if they're in your suitcase and which one's on top. Hopefully not. Here's some more practice. Seating assignments. Hopefully that's obvious that position matters. This one most of you have never bought lottery tickets and don't know how they work, but basically it's about picking numbers, generally not position, although I hear they've introduced some since in the last decade or so. Picking members of a committee. So if we did the prom committee, it doesn't matter what order you're picked in, you're all pretty much the same level. If I picked 3 winners, say I gave out 3 bags of Cheetos, you don't care if you're picked first, second, or third, the position doesn't matter as long as you get those Cheetos. Picking first, second, and third place, though, you do care very much. You'd rather be in first than second or third place. Alright, since order does not matter, or position does not matter, in combination problems, how can we adjust the permutation formula for combinations? Alright, well, let's say I'm going to write this combination formula. It looks just like the symbols here, looks just like permutations, but it's got a C for combination. And we're going to start out with the permutation formula. Alright, well, how did we get 12 to 6? We divided by 2, which was the number of ways to arrange Ellie and Braden. So if I divide by, maybe I just need to divide by the number that I pick, right? Well, the problem is I can arrange Ellie and Braden 2 ways. But what if I picked 3 people? Ellie, Braden, and Zach. Do I only have 3 ways to arrange them? Hopefully you remember that I actually have 6 ways to arrange them. And if I did Ellie, Braden, Zach, and Michael, how many different ways do I have to arrange them? Well, I actually have 24. Well, that's not R, that's actually R factorial. So I'll do nice exclamation marks here. So we fix it by adding this piece, which is dividing by number of ways to arrange our items. Alright? We'll do 2 quick, we're almost done. So, good news, on the calculator, there's an NCR. It's right next to the NPR, so I won't even write the steps for it, okay? We're going to calculate the number of ways. You can pick 5 cards from a deck. You should know there are 52 cards in a deck. I'm picking 5, so I'm doing 52C5. Now I'm going to go ahead and show you what it looks like in the formula. So that'll be 52 factorial all over 52 minus 5, which is 47 factorial, right? And then divided there by 5 factorial. But I'd much rather use my handy dandy calculator. So I go 52 first, math, go to PRB, look there it is, third choice, and then put 5, and that tells me the answer is 2,598,960, which tells you how many hands are in a poker game. That's how many different possible hands there are. Alright, pick 3 free apps from a choice of 10 apps. So to choose from, we have 10, and R is 3. So we're going to do 10 combination 3, which is 10 factorial, all over 10 minus 3 factorial, and 3 factorial. Which, if I go ahead and use my handy dandy calculator, 10, math, PRB, NCR, and then put 3, enter, I get 120. There you go.